So we'll do a simple problem based on free body diagram. See, the question goes like this. A car weighs 1800 kg. The distance between its front and back axle is 1.8 meter. Its center of gravity is 1.05 meter behind the front axle. Determine the force exerted by the level ground on each front and back wheel. Okay, so this is basically the question. Alright, now see, remember we are talking about the free body diagram, correct? So what all forces will act on it, and then how we have to take the forces, all these things will come into play. Okay, alright, see, now see, look at this figure. See, we have the front wheel and back wheel, and then this is the center of gravity. So basically here the weight comes into play, correct? Right, now next thing what we have, see, the total distance is 1.8 meter, that we already know, and the center of gravity is 1.05 meter behind the front axle, right? So that means this distance is 1.5, correct? Alright, so now what we'll do is, see, we'll take normal reactions because weight is downwards, so normal will be upwards, Newton's third law of motion, correct? So we have, let's say, N1 be the normal reaction on the front wheel and N2 be the same thing on the back wheel. Okay, so now what we have, see, how many wheels? There totally, basically there are 4 wheels, correct? So we have 2N1 plus 2N2, 2 in the front, 2 in the back. So 2N1 plus 2N2 is equal to W, because this is of vertical equilibrium. Okay, so 2N1 plus 2N2 is equal to W. Call this as equation number 1. Okay, now what we have to take is, with respect to G, what is the moment of all these forces? Okay, again I'll tell you, with respect to the center of gravity, what is the moment? Okay, so what we write is taking moments about G. Okay, so what we get is 2N1 into 1.05. So let me explain how this comes. 2N1 is what? It's the normal force on the front wheel, correct? So 2N1, what is the distance of those two wheels from the center of gravity? 1.05 meter. So we have 2N1 force into the perpendicular distance, which is 1.05. This is basically moment of a force, right? So we have 2N1 into 1.05 is equal to 2N2 into 1.8 minus 1.05. Okay, why these two should be equal? Because if those two are not equal, then the car will topple, correct? Or the car will rotate. But since it's at equilibrium, the moment of force on the front wheel and the back wheel should be the same, right? This is the reason we have 2N1 into 1.05 is equal to 2N2 into 1.8 minus 1.05. Okay, so we'll write N1 in terms of N2. That is, N1 is equal to 0.75 by 1.05 into N2, or N1 is equal to 5 by 7 N2. Okay, so this is equation number 2. Now what is given weight? 1800 kg, correct? So here what we can substitute is, in place of N1 we can substitute 5 by N N2, correct, in equation 1. So we have 2 into 5 by 7 N2 plus 2 N2 is equal to 1800. Alright, or if you simplify this, we get 12 by 7 N2 is equal to 900, right? Or N2 is equal to 900 into 7 by 12, or 525 kg weight. Okay, so 525 kg. Now remember, we are talking about the force exerted, correct? So since the force exerted is what we need to calculate, so we have to multiply that by 9.8. Okay, so we'll get 525 into 9.8, which gives us 5145 Newton. Okay, so this is basically the force exerted by the level ground on N2, right? N2 is what? Back wheel, on the back wheel. Now same way we have to do even for the front wheel, correct? So use the relation N1 is equal to 5 by 7 N2. Okay, so you'll get 5 by 7 into 5145 Newton. Okay, we'll keep the Newton as it is because N1 we'll get in terms of Newton, correct? So we'll get the answer as 3675 Newton. Okay, so the force exerted by the ground on the back wheel is 5145 Newton and on the front wheel is 3675 Newton. So this is how we solve a problem using free body diagram. See, we have moments of force everywhere. So we have downward force, so we take the normal, which is upward, and then we take the center of gravity. From center of gravity, we calculate moment of a force, which is basically the torque. Since we have rotational equilibrium and translatory equilibrium, so we take that sigma f equals to 0 and sigma tau is equal to 0. Okay, so that's how we get the answer for the given problem. So all the free body diagrams, we have to use the same principle. Okay, so everywhere we get the weight, the normal and the moment of a force. Okay, so we solve problems based on forces using free body diagram.